Wagwan everybody, it's your boy Mr. H again. Today we're back with some more projectile motions. As I said in the previous video, there are multiple ways to solve these kind of questions, and there are multiple ways which these questions can be asked. So I'm just showing you multiple variations just so that the concept solidifies and you guys know what I'm talking about. So here the question asks, a soccer ball is kicked at 35 degrees above the horizontal. It lands 13.8 meters away and reaches a maximum height of 2.42 meters. So, and then they asked four different parts of questions. So the first thing, which I always like to do, is I like to resolve the forces, okay? Or I like to draw a diagram, okay? So let's say this is a playing field, right? The ball was kicked at 35 degrees. Okay, let's just put an arrow there at 35 degrees. Okay, and it landed somewhere here, which is 13.8 meters away. Okay, so that's that distance. And it reached a maximum height. So if I were to draw a dotted line parabola, it reached a maximum height of 2.42 meters. Yeah, this is a pretty weak kick, but you know what? It is what it is. So the first question asks, what is the initial velocity? What is the initial vertical velocity? Okay, now to find vertical velocity, we need to know a couple of things. So first of all, I like to use V and U in my terminology for initial and final. So my V is going to be my final, and my U is going to be my initial. All right, I will also just make sure that I reiterate both of these things for you. And the second thing I'd like to tell you is that, remember, two forces which are 90 degrees apart, or any two forces or two movements, any two velocities, but if they're 90 degrees apart, they do not have any influence over one another. So if something's in the x-axis, it has no influence on the y-axis and vice versa. Okay, so what is the initial vertical velocity? So we need to find v initial, or sorry, the u in the y direction. Okay, now what is another thing we know? We know that the max height, so the distance it traveled, was 2.42 meters. Okay, we know the force of acceleration of gravity is 9.8 meters per second squared. Okay, so here what I can use a formula. I can use a formula to be S is equal to, can use, sorry, actually, I'm going to use V squared is equal to U squared plus 2AS. Okay, and these are the equations of motion which we have to know. We have to memorize them. So I know that at my maximum height, there's no vertical force because the ball up here is going to have a vertical velocity of 0. Okay, so we know my final is 0. I can cancel that out. So that I can say U squared is equal to negative 2AS. Okay, so, and I'm going to say U squared is equal to negative 2 times negative 9.8 because acceleration is the downward direction, so it's negative value, times 2.42. Okay, so then this will become U squared is equal to 47.43, and square rooting both sides, U is equal to 6.89 meters per second. So this is my initial velocity in the y direction. Okay, part B asks, how long does it take to hit the ground? So now to take how long, that's a total flight time. Okay, now one thing you have to know, if you ignore air resistance and friction, at your maximum height, that's t half, and the other side will of course will also be t half. So if you can find the time of this, you can just multiply by 2 to get the total time traveled. This is just one of the tricks which you can use, right? So that's what I'm going to do here. So to find how long does it take to hit the ground, I know my final vertical velocity was 0, so my v in the y direction is 0. I found out what my u was. My u in the y direction, or my initial velocity, was 6.89 meters per second. I know the force of gravity is equal to 9.8 meters per second square, and I need to find my time taken. And this time, I'm just going to put in brackets, is going to be the half the time it takes for half the journey because it's a full parabola. You cannot apply this to, if you, let's say, throw something off a cliff or it's halfway distance, you can't apply this kind of technique. You just have to be kind of intuitive with it. So I'm going to use the formula V is equal to U plus AT. My V is 0, that gets canceled out. I know what my U is, and so I can say that negative U is equal to AT. and this is going to go negative 6.89 is equal to negative 9.8 meters per second squared. I'll just not write that. Times t. Okay, so then t is equal to negative 6.89 divided by negative 9.8. The negative and negative cancel. My t is equal to 0.703 seconds. So now remember, this was half the time, right? For half the parabola. So for the full parabola, it become 2 times half of that. So it become 2 times 0.703. And my time is going to be 1.41 seconds. So my total time taken for the whole journey is going to be 1.41 seconds. I hope that makes sense. Now we'll move on to the next part, which is part C. And for part C, it asks, what is the initial horizontal velocity? So now, what is the initial horizontal velocity? Now remember, horizontal velocity, like I said, will not change throughout the whole journey. Okay, this is because that the only other force acting on it during its journey is in the vertical direction, which is acceleration, or the force of gravity. And that, remember, I said it acts in the y direction, so it has no effect on the x. So I can say that I can simply use the formula. I have my total time and I have my distance. I can just use a simple speed formula. V is equal to S over T and solve it. So I can say 13.8 divided by 1.41 seconds, which I found the last part. And my horizontal velocity is 9.79 meters per second. Okay, remember, don't forget your units, and don't forget if your teacher or your professor is very strict with their decimals and their significant figures, so just make sure you adjust accordingly to your answer. Okay, now the last part asks, with what velocity was the ball initially kicked? So initially, we know that the ball, we found out that the vertical was, if this is the ball, it was kicked at 35 degrees. Okay, and we know we just found the initial horizontal, which was 9.79. We found the initial vertical in the first part, which was 6.89. So if I were to find the if I were to find the initial speed, if I just move this arrow over here on this side and just draw it up here, it's a bit too big. So what we'll do is erase that. And we'll just continue this line over here. And if I move this 6.89 on this side, just put a dotted line, 6.8. Now this is my y direction, of course. Does this not look like a right angle triangle to you? And this is going to be, if this is my angle, this is my opposite, this is my adjacent, this is my hypotenuse. So basically I want to find my hypotenuse. So we'll simply use Pythagoras theorem. So what does Pythagoras theorem state? It will be my velocity square, or c squared is equal to a squared plus b squared. So it become 9.79 square plus 6.89 square, and we'll just simply solve this. Okay, so v square is going to be equal to 143.32 meters per second, and square rooting both sides, my velocity is going to be equal to 11.97 meters per second. So the ball was initially struck at 11.97 meters per second at an angle of 35 degrees above the horizontal. I hope all of this makes sense. If you guys have any other questions, or would you like to see some similar videos, or have anything about physics, chemistry, math, or biology, please leave them down below, and I'll see you on the next one. Peace.